So we just said that if you're running LINQ queries on very large in-memory collections and running those queries many times a second, then you could find a performance issue. And I recently spoke to a C# developer who was in this exact situation. He was working on a game, and in many games there's what's called the game loop, which basically is the same code running over and over again, many times a second. It's making decisions about what will happen next in the game, with many different characters or items in the game moving to new positions and making decisions about what they'll do based on where they are now and what they're in proximity to. And this particular game made heavy use of LINQ inside its game loop. And of course that's great from a code readability perspective and probably made development a lot easier. But game developers usually want to eke out the maximum performance possible from their game. And so this developer told me that he'd made some performance measurements and found that he could speed this game up just by converting all the LINQ queries back into plain old for each loops. Now you might be wondering, what sort of performance gains would I get from abandoning LINQ? How big a performance cost is it? Well, let's do a very simple experiment. Here I've got a LINQ query that operates on a sequence of 10 million items. It's got 3 select statements, each performing a fairly simple mathematical transformation of the input. And then I've done exactly the same thing below, but with a for loop, containing 3 statements corresponding to each of the 3 steps in the LINQ statement. And I've used a stopwatch object to time this and see how long it takes. Let's run it and see what the difference is. As you can see, the non-LINQ version is faster, but not massively so. It's about 10 to 20% faster. Obviously, if we wanted some accurate results here, we'd perform this test many times and on several different computers as well. But this is roughly the sort of performance increase you could expect from switching from LINQ to for each statements. Now, if you're wondering what's causing this performance difference, it's mostly the overhead of having to make more method calls in the LINQ version. We have to repeatedly call these lambda expressions, and even the for each loop under the hood is calling a move next method many times on the IEnumerator interface. Now, in most cases, the time spent running the methods inside the pipeline greatly outweighs any overhead that LINQ itself is adding. But still, in performance critical code, this might be a big enough difference for you to decide that you can do without LINQ. So, does this mean that you have to abandon LINQ whenever you're writing performance critical code? Well, not necessarily. Let me show you a couple of tricks that can improve the performance of your LINQ code.